7.4, we've got parallel lines and proportional parts. So we're going to look at, still again, your proportions within a triangle, and then when we just have parallel lines, okay? Not a triangle, but it'll look like parts of triangles, okay? So the first one we're looking here is this is called the triangle proportionality theorem. It says if a line is parallel to one side of a triangle, so parallel to one side, and intersects the other two sides. So notice that it intersected the other two sides of the triangle. It's parallel to the one, it intersects the other two sides. Then it divides the triangle into segments of proportional lengths. So where we did before, we did the whole side over, like the long side over the short side, which we can do and it'll work, but this is when the lines are parallel, okay? If they're parallel, we can jump that and we can actually make it even easier.
What does that last thing say?
Proportional. Is that really bad handwriting? I'll zoom in here. Smaller screen, it's harder to write. P-R-O portion. No. Does that make sense? Which means we're going to get proportions, which means two fractions equal to each other again. So here we go. What this means is that AE over, give me another segment. I picked AE. You give me another segment. AE over what? AD. Okay. So you went this side to the other side equals, make sure we go in the same direction. Since AE was on the bottom, EC is on the bottom. Down here. EC over what? DB. Yeah. This is only when those sides are parallel. Got it? If they're not parallel, you can't do this. You'd have to go through the whole side and partial side, okay? We good? All right. They're parallel. I want to find SU. I want to find X. Set it up for me. What you got? What do you guys got? Anybody? Nobody? John? No clue how to do this?
Portion.
I did RT over T.
I did 8 over T and 12 over X.
So you said 8 over 3
Yeah.
and 12 over X? Yeah, that works.
But we're doing the letters.
No, we're finding the variable X, what it measures. So 8X equals 36. And divide by 8.
Yeah.
4.5.
It's contagious. I saw your draft.
What about the second one?
That's nice.
What you guys got on the second one? 4 over 10.5. Hey guys.
It's not me, it's him. Not me. No, dude.
Hey. Listen. All right. So I got 4 over 10.5 equals what over what?
6 over X.
Okay. So cross multiply. I'm going to point something out to you guys here in just a second. I want to make sure you understand. So 6 times 10.5 is 63. Divided by 4. 15.75. pointing this out, listen. This is not giving me the length of the parallel sides. Understand? It's giving me the sections of the two sides. If I were given the length of these two, I would have to go by the whole length of the side. So like if I knew that the side AC was like 20 and I wanted to find YX, this is the whole triangle. So I'd have to do, if this were 20, I'd have to do 20 over 14.5 equals Y over 10.5. Because this is the big triangle. What we're doing today is not with the parallel lines. It's with cutting the sides into two parts. Yes, no. Not until you get into it.
I gotta do it.
You got to do it. I know. Go. All right. So, just FYI, the converse also works. That means we can go the other way. If we know that the sides are proportional, then we know that the shape is that the two lines are parallel. Sorry. So here we go. DH is 18. HE is 36. DG is half of GF. So let's label DG.
Why would they just label it for us since? Why do they make us label it?
I agree.
Difference.
I think on your work it labels it all for you.
Yes, sir.
All right. So there we go. It's set up. Now tell me what X is going to be.
How do you set it up if you have two X's?
You still set it up the same.
You would?
Mm-hmm. What do you got?
Gee. I would do like.
Jackson, John.
Okay.
Here.
Wait, is the 0.5 X? That's for both X's, right?
No, it's just on the top one.
Oh.
Anybody? Set it up.
18 over 36. And then 25. X over this.
Okay. So these cancel out. What's 18 divided by 36?
25.
So 0.5 equals 0.5.
Sorry for fixing that.
So does that equal? So are those lines parallel?
Yeah.
Yeah, if they're equal, they're parallel. One more. We're going to determine whether they're parallel, okay? YX, or XY, is 15. YZ is 25. WA is 18. And AZ is 32. Set it up for me. What do you got?
18 over 32 and 15 over 25.
Are those equal? You can either do the fraction or you can cross multiply.
I should have made it.
18 divided by 32 is 0.5625. Are you listening? 15 divided by 25 is 0.6. So are those lines parallel?
No.
No. All right, mid-segments. Mid-segment of a triangle is a segment with endpoints that are the midpoints of the two sides of the triangle. It's a segment with endpoints that are the midpoints of the two sides of the triangle. Okay, so looking down here, EB is the mid segment of this triangle. Now notice those lines are not parallel. Okay? Not parallel lines. So yeah. So actually, there's actually 3 mid-segments because I didn't think about going this way. See them? 3 mid-segments. Because it can be between any of them. So down here, this one would go with this, and then the blue one would go here. So there's 3 mid-segments in every triangle. And actually, I was wrong. A mid-segment of a triangle is actually parallel to the other side. So, a mid-segment of a triangle is parallel to one side of a triangle, and its length is actually half the length of the other side. So EB in this right here, EB is half of DC, which that makes sense because it's the mid-segment. It's in the middle, so it's half of that segment. You guys see that? That was my bad. Let's do a couple problems here. DE and EF are mid-segments of triangle ABC. We want to find AB. Here's AB. How long is AB? Huh? You don't know? Which one would be the mid-segment that is parallel to AB? What's the line parallel to AB? ED?
Is the mid-segment?
Wait, so it's AB 10?
Yes, AB is 10.
So it's always going to be half?
Mm-hmm. Yeah, it's half. If it's a mid-segment, it means it's middle, in the middle, so it's halfway. So if this one's 5, this one is 10. So question knowing that now, how long is EF? How long's EF?
5.
Not 5. EF is not 5.
7.
Not 7. Where'd you get 7? You guys see EF?
Oh,
Wait, so it'd be
wait.
18 divided
It's
by
18 divided by 2. So
9.
9. Yes, very good. It's 9. Very good. Depending on which way. You went smaller, so you half it. Whereas on the ED to AB, you went larger, so you doubled it. Yeah.
Now we can find AE and CE and...
Yeah, you can find them all now, actually. You can, because they're midpoints. So it's half of them.
Like,
So this is 5 and this is
the
5.
ABCD, ABC squared, AC, Pythagorean theorem, that's what I was thinking.
So what is the angle AFE? Because you know they're mid-segment, so you know they're parallel. So what's that angle AFE up here? What's this angle? Do you guys know?
Yeah.
Do you guys remember that one? Parallel lines?
Which one are you looking for?
AFE. Angle AFE.
Oh, we're doing angles.
Yeah, the angle AFE.
So it's
180 minus 87.
Not
No, I
80
think
minus
it's
87.
87.
It's 87 because they're alternate interiors. Yeah. So these are congruent because the lines are parallel. All right. So we're going to skip the top one. I think you guys are good on it. The bottom one right here. We don't have to make a full triangle. If we have 3 or more parallel lines, if they're intersected by a transversal, then they cut the transversal proportionally. So set up a proportion for me, guys. This will be letters, not numbers, okay? Let's go AB over what?
EF.
EF equals what over what?
EC over FG.
Yeah. You got it. That's it. Jerry, you're on fire today.
What's happening?
So AB, the length of segment AB
Uh-huh.
over the length of segment EF, because they're in the same spot, equals BC over FG.
What are we trying to solve?
We're not yet. We're just setting up, make sure we see the right things to go together.
Yeah.
I feel that.
Sometimes we have to give letters to. All right, we're gonna.
The mom got it.
Oh, check this one out. This one's neat. If, and we're not give words. See how AB is congruent to BC right here? See how AB is congruent to BC?
Yes.
How are EF and FG related then?
Oh.
How are EF and FG related?
They're equivalent.
Yeah, they're congruent. Yeah, they're not congruent to the other side, but they are congruent to each other. All right?
Wait, what?
Because of the proportion?
How do we know that the lines are kind of like? Just kidding, they're all parallel.
Yeah.
Wait, you can have.
As long as those transversals are parallel, you're good.
That is not a parallel though. It's a pair of L's, not tri-L's.
But this is like a triangle cut into several parts. Think about
That's
that.
like, you can't have 3 pair of L's.
Yeah, you can. Why not?
No, because it's a pair. That's 2.
Oh, you're funny.